Assalamu alaikum wa rahmatullah. Welcome everyone to Engineering Economy. Today we'll have two chapters, 14 and 16, together because they are both are related to each other in terms of the concept, and they are short chapters, but the implementation of those chapters always comes together. Chapter 14 is about the inflation, and chapter 16 is about the depreciation. The concept somehow it is relative. The inflation comes when the value of money decreased, and the depreciation is when the value of the asset is decreased. In chapter 14, the inflation, before we start with the chapter, there are some definitions need to be clarified to understand the concept. The inflation, as we said, is the decrease in the amount, the value of money. So, in other words, the decreasing in purchasing power. You have to pay more to get the same product or the same service, and that's the meaning of the inflation. There are two terminologies needed to be known: the CV, which is the constant value dollars, and the future dollars. The constant refer to the current or today's value of the money or the purchasing power, and the future dollars is mean the amount of money in the future after inflation is being applied. The CV and future value, they have a relation in these equations. To convert from one to another, you need one of those two equations. If you have the future dollars and you need the current or the constant dollars, you divide the future dollars over 1 plus the inflation rate to the power n, which is the number of years. And if you want the current value dollars and you have sorry, you want to find the future dollars and you have the current dollars, you multiply it with the 1 plus the inflation to rate to power n. The inflation is an interest rate, but it is different than the constant value change over time. Inflation, something happened radical and significant into the value, so it is considered to be additional interest rate comparing to the regular change value of money. So the concept, it is similar to chapter 2, value of money change over time. The difference here is the addition of the inflation rate into the interest rate that happens regularly over the time for the value of money. And to use this inflation concept, in order to find a current value or a future value, we will refer to the same concept of chapter 2. But if the question or if the problem I have is just to change from a future dollar value to a constant dollar value without considering the interest rate, then the only two equations that we have covered here, it will be enough to convert between current into a future. But when we want to apply the interest rate, then the P given A and A given P and all the terminologies for formulation will be needed, as we will see in the coming example. In this example, only needs you to convert from a constant dollar value, which is the current value, into a future value when you have inflation has a constant average of 4% per year. So it is similar to how is the representation of the inflation. It is similar to the interest rate or rate of return. It is a percentage per year. And if I have the number of years, which is 30, and I have the value of the constant dollar value, 1,000, even though it says 30 years ago, that means this is referring to the value of the money on that time, which is the constant value, before the inflation happens. And if you want to find the value of the money after the inflation is being applied over these years, you just follow the formula that convert the value from current value or constant value into a future value by multiplying it with 1 plus the inflation rate, which was given here as a 0.04 to the power number of years, which is 30. That will lead us to the value of the future after the inflation is being applied. So the $1,000, it is equal to $3,243 after 30 years when the inflation is being applied. As we said here, we are not taking here the consideration of the time value of money and the interest rate. But if we are going to do so, then we will follow one of those two steps to solve the problem or convert the value of money over the time with the consideration of the inflation. We will show an example of a present worth analysis. Either of two or one of those two methods, both of them give you the same answer. It is your preference how you want to do it. You have to change the value first. In the first method, you have to change the value of the constant value using the future dollars divided by 1 plus the inflation rate to the power n. And then you can use the constant value of money or the CV value with the given interest rate. So usually problem that include inflation and interest rate, it will be clear by having two different interests. One, it will refer to as interest rate, and the other one, it will refer to it as inflation rate. When you have some cases like that, then you will focus first on one of those two methods. Either you find the constant value of money based on the inflation percentage, then you find the value of money using P given A or P given F with the given interest rate from the tables. The other method is you have to convert the interest rate itself, and we call that the interest rate adjusted for inflation. This formula will calculate the interest rate with the consideration of the inflation. Then you can use it directly to solve the problem. Let's see an example. Here a machine will have a cost of $25,000, a future cost 6 years from now. Even it didn't say future cost since it is in the future, so it is something referred to the future. And ask you to find the present worth of that machine if the real interest rate is 10% and the inflation is 5%, using the CV method or the inflation, adjusted inflation or adjusted interest rate for inflation method. Now we have a future value. We want to find it in the present, considering both the inflation and the interest rate. It is different than the previous example when we didn't consider the value of money or the interest rate. Now, when we consider both of them and we want to find the present worth in this case, what we do in the first method, the CV, you change the value of money first and find the constant value from the future value. The future value is the 25 divided by the formula 1 plus the inflation rate to the power n. And this will lead you to a value that is for the constant or the CV value. Then you can use the CV value P given F, because it is in the future, using the interest rate as a 10% as it's given in the question. The second method, I prefer, my personal view, I prefer the second method. But maybe for the ease of use of tables, students, they go for the first one. The second method is you change the interest rate from the beginning. So you consider the 10% and the 5% of the inflation. Using the formula here, which is the I, referring to the interest rate, plus the inflation rate, plus the inflation times the interest rate. So you apply them to this formula, and this is the adjusted interest rate for inflation, which is 15.5. Then you use it as is for the future cost you have and find the value of the present worth. This is more easier in terms of the concept. This is more easier in terms of the tables, because you will have some fractions here, and those fractions would require from you maybe use interpolation. But in this step or this method, it is easier because you are using each interest by individually. So you are going to find at the end the interest rate using the tables without need for the interpolation. But you have to do the change of the future value, or for the future value of money that is affected by inflation, into a constant value or CV. Then you can use the CV with the interest rate that is given. This is how you conduct the present worth analysis when you have inflation. It is similar to the same concept in the annual worth, but we will not cover the annual worth examples using the inflation, but it is the same concept. And we are not going to also use a different number of years in terms of the project selection. It will be just a study case by case. For example, like here, I have 3 alternatives, but here we are going to consider that the study based on the present worth value, considering the inflation. I have 3 different alternatives. First alternative is investing 100,000 now. The second one is I have 8 payments for 8 years, and each payment is 15,000. And the third option is 3 payment, 45,000 each, but they are placed on year 0, 4, and 8. Now, what is the difference between these problems and Chapter 5 problems? When you see that the inflation rate is given, then the concept here is different. The concept here is referring to the inflation and the value of money. And to apply the present worth analysis in such cases, the first problem or the first alternative didn't need any changes, so it is considered to be the same, no changes. In the second one, I have an annual value that is appear yearly every year for 8 years. And to convert it using the method of the interest rate with the inflation, in this case, the solution used the adjusted interest rate for inflation. That means converting the interest rate and the inflation and find IEF, which found to be 10.24. Then you use the 10.24 in solving all the problems without need to change the value of the 15,000 and the 45,000 every time. So therefore, it will be easier to use the adjusted inflation rate when you have multiple alternatives. If the question asks you or direct you to use one of the methods, then you have to use it. If the question didn't ask you, then it is up to you to use the method. So in this question, it asks to use the approach 2, which is the interest rate adjusted for inflation. After you convert the interest rate, just change the value from annual to present using P given A. For the IF, not the I, not the F, the IF, the interest rate adjusted for inflation, for 8 years. Now you go to the table and do the interpolation or use the formula to find the value. For plan 3 or alternative 3, the first value placed on year 0, no need to change it, but I have 2 single values appeared in year 4 and 8 respectively. So I have to change them to present from future using P given F for the IF again, not I or not F itself. You have to find the IF to use it, again using the tables or the formula, and then you select the value that is the best present worth in that case. And in that case, consider to be 100,000 for the plan one is the winner, because it is going to consider that as an investment and is going to be considered not a cost. So in this case, is not a cost. It has to be clarified from the beginning whether it is a cost or investment. In this case, it was an investment, but if there is a cost, then you will go with the larger numerical value, regardless if it is plus inflow or outflow cost. This was for the inflation. It is very small chapter. And the chapter 16, which is the depreciation method, it is similar in terms of the concept. We will answer all the questions at the end, so we can have the saved recorded session for the lecture view, and then we will answer all the questions. We will have enough time. The depreciation concept, it is decreasing in the value, but not the value of money, but it is in the tangible asset. So both of them consider decreasement in the value, but they're in the value of money. So you need more money to pay for the same product. And the depreciation is the decrease in the value of the asset itself. There are another terminologies need to be clarified before we proceed. And you have to pay attention here to one thing that it is very important to know, which is the salvage value and the book value. I will explain them, but pay attention to them. The first cost is usually known from chapter 5. It is P. Here they can call it also B, as referring to an adjusted basis, which is the total installed cost for the asset, the initial cost. The book value. What is the book value? It is the remaining under precipitated capital investment in year T. What does that mean? Is the value of money, the value of the asset at a certain time of use. After you use the car, let's say 1 year, then the book value of year 1, which means T equal 1, is the value of that car after 1 year of use. Okay, if we said book value 2, that's mean the value of the asset that is worth at year 2. How much is it from the original? This is what we call it the book value. Okay, so the book value, the remaining capital investment, the remaining capital investment. Now let's go and see what is the recovery period. The recovery period is the depreciation life for the asset in years. The salvage value is different than the book value because it comes at the end of the life of that asset. So if the estimated life for that equipment or that machine is 20 years, then the value at 20 years considered to be a salvage because it is at the end of its life. The depreciation rate, or DT, is the fraction of first cost or basis removed each year. That's mean every year how much you will detect from that asset's cost, original cost, how much you are detecting. Every year, this is considered the depreciation rate. Their formula are very easy, and those are the only two formula will be used, which are the depreciation value and the book value. We are using here a straight line depreciation rate. There is another nonlinear methods, but here we are just going to cover the straight line or the linear depreciation. The depreciation at a certain time is equal to the present or the initial cost or the principal cost of the machine minus the salvage divided over the N, which is the number of recovery period. And the book value is the value of the initial cost or the principal minus the time times the D, which is the annual depreciation charge. Let's see an example how problems for depreciation look like. A gas processor has a first cost of 20,000 with a 5,000 salvage value. So the first cost or the principal or B is 20,000 and the salvage, which is S, is 5,000 after 5 years. That means the number of years for that machine is 5. Find or calculate the annual depreciation BV for year 3 and plot the book value versus the time. To find the annual depreciation, which is the D, we need to find or calculate the formula that is the D times B minus S, which was given here, B minus S divided by N, the principal minus the salvage divided by number of years. This will be the depreciation annually. So every year you are going to lose 3,000 of that 20,000 of that cost. This is even applied for cars. Some countries, they have book value and depreciation for every brand, for every make of cars. So it will be a reference for auctions and for people they want to buy a used cars. The book value at year 3, and it can be requesting book value at year 2 or year 1, it doesn't matter. So the book value at year 3 will be the principal minus the number 3 that is referring to year number 3 and the depreciation which was found in part A. This will be equal the book value. If you want to sell or you want to purchase that equipment after 3 years of use, it will worth or it will cost $11,000. To plot the diagram, you can do that using Excel by finding the values over the given 5 years, and then you plot the horizontal axis for number of years and the vertical for the book value for all the 5 years. That was all for the depreciation and inflation chapters. Now it is the time for the questions if you have for any of the subjects.